Suppose that we're given a function parametrically. That is, x is some function of t and y is some function of t. We saw in a previous video how to find dy by dx using the chain rule. Let's remind ourselves of that now. dy by dt equals dy by dx times dx by dt. That's just using the chain rule. This then implies, if we rearrange it, that dy by dx is equal to dy by dt divided by dx by dt. But now, suppose we wanted to calculate the second derivative of y with respect to x, d2y by dx squared. Then we'd need another application of the chain rule. Basically, we apply this formula but replace y with dy by dx, so the formula becomes d by dt of dy by dx is equal to d by dx of dy by dx times dx by dt. So, by rearranging as we did above, we obtain that d by dx of dy by dx, which is just d2y by dx squared, equals d by dt of dy by dx divided by dx by dt. Let's put that derivation into practice and actually solve an example. Let's take x is equal to t cubed plus 3t squared, and y is t to the 4 minus 8t squared. Then dx by dt is 3t squared plus 3 times 2t, which is 3t squared plus 6t. dy by dt is equal to 4t cubed minus 8 times 2t, which is 4t cubed minus 16t. So now we have dy by dx is equal to dy by dt divided by dx by dt from the first part of our derivation, which is 4t cubed minus 16t divided by 3t squared plus 6t. Now we do some rearranging so that this expression will cancel a bit. We take 4t as a factor in the top line, leaving t squared minus 4, and on the bottom line there's a common factor of 3t, leaving t plus 2. Now, on the top line we have a difference of 2 squares, that is t squared minus 4, which is 2 squared. So we can rewrite the top line as 4t times t minus 2, t plus 2, and the bottom line remains 3t times t plus 2. Now we can easily see some cancellation. T plus 2 cancels with t plus 2, the t and the t cancel, so we're left with 4 over 3 t minus 2. Now we want to compute d2y by dx squared, so the first thing we should do is find d by dt of dy by dx, which is d by dt of 4 over 3 t minus 2, which is d by dt of 4 over 3t minus 8 over 3, which is 4 over 3. Now, we want to find the second derivative of y with respect to x. That's our end goal. We've computed d by dt of dy by dx, so, looking back at our formula, we see we just need to divide by dx by dt. Thankfully, we have already calculated dx by dt in the first part of the answer. So d2y by dx squared is equal to 4 over 3 over 3t squared plus 6t. And now if we tidy this up a little bit, it can be written as 4/3 over 3t times t plus 2, which could also be written as 4 over 9t times t plus 2. That's taking the 3 in the denominator of the top line to the bottom line.